We now have just over 29 minutes left in this build and hold at the 3-hour mark, and our pre-launch operations are continuing to go along rather well here this morning. The launch team is continuing to track the vehicle out at the pad and working no problems of note and nothing that would get in the way of a 1050 launch. The 7 STS-55 astronauts have been up about an hour and completed their breakfast several minutes ago and are now in the midst of a weather briefing with some meteorologists at the Space and Meteorology Group at the Johnson Space Center in Houston. The weather forecast for today's launch here from the Kennedy Space Center is a very good one. The odds are still at 80% chance of acceptable weather, but in the ongoing briefing, the meteorologists were very optimistic, and it appears that we're definitely go for launch here at Kennedy. Out at the shuttle landing facility, the weather is also expected to be good. Right now we have a red condition out there because of some ground fog, but that should be burned off within the next couple of hours and will certainly be gone by the launch opportunity at 10:50 this morning. Likewise, on the other side of the United States, weather is also good at Edwards Air Force Base. In the event we had to go in there after one orbit or as an emergency landing site, it's dry out at the desert landing field, and it would be a good site today. Across the oceans, the weather is continuing to be monitored, but we think Banjul in the African nation of the Gambia will be a good transoceanic abort landing site. We've had a weather aircraft flying around Banjul this morning, and the notes being taken from the pilot there show visibility at about 6 to 8 miles, which is good, but it has been as low as 2 miles this morning. What they're worried about out there is haze that would hinder Commander Steve Nagel's visibility of the runway should we have to do a transoceanic abort landing. A little further north, the weather in the Maroon Air Base in Spain is no-go, and at Ben Guerir Air Base in Morocco, it's also expected to be no-go by our launch time of 10:50 this morning. In Spain, we're seeing weather pattern that shows an upper level low with increasing cloudiness in the Maroon area. There's also the possibility that we might have some thunderstorms at the time of our expected launch, and so Maroon is pretty much all but ruled out at this point as being a transoceanic abort landing site. Down at Ben Guerir in Morocco, we have cloudy conditions with thick clouds at about 5,000 feet. And this is also considered to be a no-go situation, in that it would definitely be a visibility problem for Steve Nagel as he tried to bring Columbia into a transoceanic abort landing in Morocco. The meteorologists out in Houston are confident about Banjul, that conditions will hold out there, and that this haze will break down over the next several hours, and hopefully we'll see visibility staying in that 6 to 8 mile range, which would give us our prime transoceanic abort landing site for today's launch attempt. Following this morning's weather briefing, the astronauts will move on down to another room inside their crew quarters, and they'll prepare with the donning of their flight suits in preparation for this morning's launch. It takes about 30 minutes for the astronauts to be outfitted in their flight suits, and after that they will board their Astrovan and make the 10-mile trip out to Launchpad 39A. With a good TAL site now in the forecast, it appears that we are definitely on for a launch this morning at 10:50, and that of course is barring that we see no unforeseens in the next few hours. We have 24 minutes left in this planned build and hold at T-minus 3 hours. This is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. The STS-55 astronauts suited up and ready for this morning's mission. Here we see payload commander Jerry Ross shooting his own home movies. Ross will be payload commander of this particular flight. The astronauts are assisted with the donning of their suits by technicians from the Johnson Space Center. Here's Tom Henricks. Tom will be making his second trip in space today, a veteran of the STS-44 flight. He's ready to fly today. The orange suits are pressure suits, which are essentially used for ascent and entry, and about the only time they're worn. Here's Dr. Bernard Harris, mission specialist on this flight, and crew's medical doctor. Dr. Harris will be making his first trip in space today. German payload specialist Hans Schlegel. Mr. Schlegel is also a space rookie today, and he will be going uphill on ascent with a catheter inside him, and this will be used to monitor any changes to his body as he goes from the 1G environment to that of microgravity. The same story goes for Dr. Ulrich Walter, the second German payload specialist. Dr. Walter will also be making his first trip today. Charlie Precourt is a mission specialist on the D-2 STS-55 flight. Charlie is also the flight engineer on this mission. He is a pilot, but primarily serving as mission specialist on this mission. This will be his first trip in space. Back live at Launchpad 39A, we continue to move along smoothly and on schedule for this morning's launch of the Space Shuttle Columbia and the 55th flight in the 12-year history of the Space Shuttle program. The launch team is looking at no big issues on the vehicle that would hinder this morning's on-time liftoff. Weather appears to be go here at Kennedy and also over at Banjul, our transoceanic abort landing site. And the same can be said for the weather out in California at Edwards Air Force Base. In this morning's weather forecast, we did get almost all green lights across the board, but there were a couple of red lights that we need to take note of. One was a low amount of visibility out at the shuttle runway, and this is due primarily to fog and mist, which is now in the air, but that's expected to be burning off in the next couple hours and shouldn't be a problem. The bigger issue centers around some detached opaque thunderstorms amples, which are less than 3 hours old. Now, flight rules say that we can't fly if these thunderstorm amples are within 30 miles of the flight path the vehicle would take on a return to launch site abort. So we'll be watching that closely. Right now they're well out of the area, but we are watching their pattern of travel, and it's possible they could be in the Kennedy Space Center area during our launch window. But meteorologists here feel that we have a good shot of going at 10:50, that the weather will be green at that time. It might cause us some trouble if we go later on in the window, but at the present time there's nothing stopping us from launching on time at 10:50. We have just over 6 minutes left in this build and hold at the T-minus 3 hour mark. Columbia is out at pad 39A, loaded with 528,000 gallons of liquid hydrogen and liquid oxygen. The astronauts are suited up and should be leaving their crew quarters in the operation and checkout building within the next 10 or 15 minutes. At T-minus 3 hours and holding, this is shuttle launch control. This is shuttle launch control at T-minus 3 hours and holding. The astronauts recently suited up inside the operation and checkout building, and we did get the satellite a little bit late on their suit up, so we're going to play a short clip to go over that again and have a chance to see our 7 astronauts flying today. Here's Commander Steve Nagel. Commander Nagel will be making his 4th trip in flight, or 4th trip in space aboard Columbia, and he is a veteran of the D-1 mission that occurred back in 1985. Behind Commander Nagel is Hoot Gibson, who is the chief of our office. And veteran astronaut Jerry Ross. Jerry is going to serve as payload commander on the STS-55 flight and has taken his own home movies prior to this launch today. Columbia's pilot Tom Henricks is being assisted with the donning of his gloves by technicians from the Johnson Space Center. These suit technicians train with the crew throughout the time, from the time they are selected for a mission all the way until the time they come back to Earth following a good, safe landing. The crew suit-up room is typically busy with activity on launch day. Here's our mission specialist, Dr. Bernard Harris. Dr. Harris will be making his first trip in space on the D-2 flight. We have 2 German payload specialists flying on the dedicated German Spacelab mission. This is payload specialist Hans Schlegel. Mr. Schlegel will be making his first trip in space today. The other payload specialist from Germany is Dr. Ulrich Walter. Again, this will be the first trip in space for Walter. Charlie Precourt is a mission specialist on the STS-55 D-2 mission. Precourt is also a private pilot and could serve as a pilot of the shuttle someday, but is now mission specialist and also serving as a flight engineer of the STS-55 mission. Those were some highlights of our suit-up activity inside the operation and checkout building. The astronauts are now in the final stages of preparing to leave the operation and checkout building where they have their crew quarters, and we'll be heading out to the launch pad within the next few minutes. We have just 45 seconds left in this build and hold at the T-minus 3 hour mark. During this hold, the ice inspection team led by NASA engineer Greg Katnick went out to pad 39A, did a visual inspection of the entire launch vehicle and the ground support equipment critical to launch. We have a warm morning here in Florida, and Katnick noted that he saw nothing really out of the ordinary, no unusual ice buildups, and that from his perspective, everything looked to be a go. Standing by to come out of this hold, we're at 4, 3, 2, 1, and we're now at T-minus 2 hours, 59 minutes and counting. Again, pre-launch events continuing to go well here at the Kennedy Space Center and over in Texas at the Johnson Space Center where Mission Control is based. The 7 crew members are slated to walk out of the operation and checkout building within the next few minutes, and we'll be seeing live coverage of that event when it occurs at T-minus 2 hours, 59 minutes and counting. This is Shuttle Launch Control. This is shuttle launch control at T-minus 2 hours, 56 minutes and counting. The 7 astronauts flying aboard Columbia today are now leaving the operation and checkout building to begin their journey out to Launchpad 39A. Kind of a full load in the elevator in the operation and checkout building with Chief Astronaut Hoot Gibson and the head of the Flight Crew Office, Dave Leestma, accompanying the astronauts, along with some security personnel accompanying the astronauts. This morning's walkout is occurring at 7:34 Eastern Time and at the height of the time when employees are showing up to work, so they have quite a good crowd of onlookers as they make their way out to the pad. Steve Nagel leading the way, followed by Tom Henricks, Jerry Ross. Hans Schlegel is following Jerry. Dr. Bernard Harris, Ulrich Walter, and Charlie Precourt. The astronauts exchanging some words with members of the news media. Quite a good showing of both domestic and international journalists on hand for this historic international flight with Columbia and a German Spacelab module. The Astro van that the crew just boarded is essentially a modified recreational vehicle that is used for their moving while here at the Space Center, essentially on the way to the launch pad and after landing. The Astro van contains special medical equipment that can be used if necessary by the crew's flight surgeon. The 7 STS-55 astronauts arrived here at the Kennedy Space Center last Wednesday morning for what they thought was going to be a Saturday morning launch attempt. Of course, we had a problem over the weekend with an inertial measurement unit aboard Columbia, and that is what pushed launch from Saturday to today. The unit has been removed, replaced, and checked out, and the new unit is working just fine. The astronauts come here to the Space
Columbia's
Center
commander,
aboard
Steve Nagel,
T-38 jets.
and German payload specialist Hans Schlegel. German payload specialist Ulrich Walter. Columbia pilot Tom Henricks to the right. Here's payload commander Jerry Ross and rookie Charlie Precourt. Dr. Bernard Harris, who will serve as the medical doctor for this particular flight.
Good morning. Thank you for coming out this morning. We're happy to be back again. This time we're going to go. I talked with the commander of that flew the Columbia the last time, and he said he forgot to tell me when you turn the key, you're supposed to jiggle it to get it started. So now that I know that, I think we'll get going. But seriously, we spent the last month doing some additional training, sent the payload crew back to Germany, and they're all refreshed and proficient on the experiments, and the orbiter crew's all set to go. So we're glad to be back. Weather looks good today. I hope it's good through the weekend, and if all stays as it is right now, we'll be gone Saturday. Thank you very much. I'd like to introduce now the pilot, Tom Henricks.
Well, like Steve said, we're going to do it this time. The last attempt provided us a little bit of excitement, but this Saturday we're in for a lot more. The abort we had on the pad, the last attempt, was not as exciting as most of the people imagined from our point of view, because it was very similar to the terminal countdown demonstration test that we conducted just a couple weeks before that. And it turned out, combined with that training and the professionalism that the launch control team showed, it actually was a confidence builder to see how smoothly things ran after the engine shut down. So again, we're here to participate in the team effort to get D-2 STS-55 off the ground and go to work in space.
Hi, I'm Jerry Ross, MS-1 and Payload Commander, and I think the whole crew is very excited to be back down here. We came in T-38s as opposed to the shuttle training airplane this time. Weather looks a lot great, much better, and we're just very excited about the mission. We have an excellent crew, and we have a very ambitious and exciting mission ahead of us, and we can't wait to get off the pad on Saturday. Thanks for coming out.
Good morning. Charlie Precourt, the MS-2, and I'd just like to say I think we've been able to take the time we've had since the pad aboard to refocus a little tighter on our objectives, and I've come to realize just how important a mission like this is to our future. When you look at what it takes to develop a mission like this, you realize just how great an investment it is in our future, and I'm really excited about it, and I hope that you'll be watching us closely in the coming 10 days, and I think we'll have a lot of good video downlink to show you to keep up with the action in the lab. So with that, I'll introduce Dr. Bernard Harris, our MS-3.
Good morning. I'll simply say that I'm glad to be back here in Florida. The payload crew has done a lot to prepare for this flight, and I'm ready to fly.
Ulrich Walter, PS1. I'm one of the German members, and there's nothing more to say except that we arrived in the right way, so I think we should take off also in the right way. And next I may introduce Hans Schlegel.
Thank you, Ulrich. I'm the second German crew member, PS2, on this flight. And as our commander said, not only we got some training, but the payload in the meantime got updated too. And I think we are all ready to fly and to try again, and have this time really conduct our experiments and get some new knowledge down to Earth. Thank you.
Thank you very much. See you soon.
This is shuttle launch control at T-minus 2 hours 46 minutes and counting. The 7 STS-55 astronauts now making their way along the Saturn Causeway in the Space Center's Launch Complex 39 area. A Saturn V rocket shown in the background. The crew is now about 5 miles away from the launch pad, and we'll be making a stop at the Launch Control Center so that Chief Astronaut Hoot Gibson and Dave Leestma, who's the head of the Flight Crew Operations Directorate, can deboard, as well as a few other personnel. Hoot Gibson will go from the Launch Control Center out to the shuttle landing facility and begin flying weather flights in a shuttle training aircraft and in a T-38 jet. Hoot will stay airborne throughout the launch, but before he'll be giving his weather recommendations back to the mission management team and also to the weather officer, Dick Richards, who is here in Firing Room 1 of the Launch Control Center. Things continue to remain fairly quiet here in the firing room as we continue with this morning's countdown leading toward launch of Columbia and the Spacelab D-2 mission at 10:50 Eastern Time this morning. No significant problems being worked. Weather here at the Cape appears to be good. Overseas, Banjul has been selected as a transoceanic abort landing site, and we're looking at no problems at the present time. At T-minus 2 hours, 45 minutes and counting, this is Space Shuttle Launch Control. This is Space Shuttle Launch Control at T-minus 2 hours 39 minutes and counting. The STS-55 astronauts have arrived at Launchpad 39A and have boarded the elevator and should be making their way to the area where they will enter Columbia. Some of the crew can now be seen on the orbiter access arm, and Commander Steve Nagel is shown inside the white room. Members of the Space Shuttle closeout crew wear white coveralls, and they can be seen pretty clearly in the monitor here. They're made up of NASA and contractor personnel. The closeout crew primarily assists the astronauts with the donning of their gloves, helmets, and the connection of emergency oxygen lines that can be pumped directly into the pressure suits. Because of the many pre-launch duties they have to do inside the orbiter, the commander and pilot typically don their helmets after they are inside the space shuttle. Once the crew is inside the orbiter, a member of the closeout crew fits them with a parachute, which would be used in the case of an emergency. The closeout team typically consists of 6 individuals made up of a team leader, a support astronaut, a suit technician, a NASA quality control engineer, and 2 orbital mechanical technicians from the Lockheed Space Operations Company. Astronaut Eileen Collins will serve as the support crew member for today's launch attempt. Collins serves as an onboard member of the closeout crew, and when she is assigned to a mission, she will become the first woman to pilot a space shuttle flight. Another astronaut, Dick Richards, is here in Firing Room 1, and Richards is serving as the flight weather coordinator for today's launch. He is seated at a console alongside the mission management team. Steve Nagel is a colonel in the U.S. Air Force, and this will be his 4th trip in space. Nagel last flew aboard STS-57 and the spaceship Atlantis, but he also flew aboard the D-1 flight in 1985. D-1 was the first joint Spacelab mission between the United States and Germany, and today's flight and the subsequent 9-day mission, of course, is a follow-up to that original flight. Payload specialist Hans Schlegel can be seen in the monitor, being outfitted with his entry apparel, or ascent apparel. Schlegel is one of 2 German payload specialists selected to fly on this historic mission. Schlegel is a native of Oberlingen, Germany, and he will be working closely with fellow countryman Ulrich during the D-2 flight. Mr. Schlegel is married and the father of 4 children. Outside of his day-to-day job, he enjoys flying small aircraft and is a recreational runner. During the 9-day-long D-2 flight, Schlegel will work with ground researchers at the control center near Munich on experiments dealing with materials heating and processing as well as experiments involving robotics and medical systems. Schlegel was chosen to fly on the D-2 mission back in 1990, and he's 42 years old.
CMPL OTC. This CMPL, yeah, 495, perform launch pogo research valve test. Copy and work.
Within the last several minutes, our shuttle weather officer, Ed Priscillic, briefed Launch Director Bob Seek on the outlook for weather here at Kennedy and the conditions that Steve Nagel might encounter in the event we had to do a return to launch site abort. While weather is generally considered to be favorable for launch this morning, we do have some concerns with thunderstorms, which will be to the northwest of us, but possibly within 30 nautical miles of the Space Center at the time of launch. We're also looking closely at the cloud layers, which are building up a bit. Patrick Air Force Base, which is located about 20 miles south of the Space Center, has reported a cloud deck of 2,700 feet and broken, while the Titusville Airport, just to the west of the Space Center, has reported scattered clouds.
Just to let you know, the suit fans will all be turned on.
The primary concern is that we might have a ceiling below 8,000 feet. But Ed Priscillic informed Bob Seek that he didn't see precipitation as being a player for this morning's launch attempt. When astronaut Hoot Gibson goes airborne in the shuttle training aircraft and the T-38 jet, he'll be looking for the weather conditions and reporting his findings back to Dick Richards, our weather officer here in the firing room. Hoot's activities could play a big role in this morning's launch attempt, depending on how he sees conditions and visibility out at the runway. Again, we could have a pretty good cloud deck, or thick cloud deck, but the percentage of cloud cover, when you compare it with how thin the clouds are and what kind of visibility we see, those factors all come into play in making a decision for launch. Ed Priscillic noted that we'll generally be watching the lower clouds and just have to see how the morning progresses. Winds are light and well within specifications for launch. And there are no technical issues being worked aboard Columbia or any of the computer consoles here in Firing Room 1 or over at the Johnson Space Center in Houston that would interfere with an on-time launch.
Okay, copy. That's step 557. Copy.
German payload specialist Hans Schlegel is now preparing to board Columbia. During ascent, Schlegel will be seated on the middeck and to the right front of the airlock, while Commander Nagel, who entered a few minutes ago, will be seated on the left-hand seat of the flight deck. Columbia's pilot, Tom Henricks, is now being assisted with his pressure suit. Henricks served for a couple years here as an astronaut support crew member and is very familiar with getting aboard the orbiter and the proper wear of his flight suit. Henricks is a colonel in the Air Force and a graduate of the Air Force Academy and Golden State University. He's a native of Bryan, Ohio, and is a graduate of the Air Force Test Pilot School. He's also a master parachutist and has jumped from an airplane more than 750 times. He served as pilot back in November of 1991 aboard the STS-44 flight on the Shuttle Atlantis. And outside of flying, he enjoys running and windsurfing. On the D-2 flight, Dr. Harris will be the lead conductor of all medical experiments, and he will also conduct a couple of in-flight physical examinations of fellow astronaut Charlie Precourt.
And OTC, the post-ingress switch reconfig is complete.
Unique about this physical exam is that medical doctors from the Mayo Clinic in Minnesota will participate in a two-way audio and video hookup with Dr. Harris during these physical exams. When these exams are ongoing, they'll be comparing their data from a physical exam on Earth here in the 1G environment to what Dr. Harris will be seeing up in the microgravity environment aboard Columbia. Outside of medicine, Dr. Harris is an avid outdoors enthusiast and enjoys sailing, running, scuba diving, and snow skiing. Over his career, he's received many professional and community awards, and he's married to the former Sandra Faye Lewis of Sunnyvale, California. The couple have an 8-month-old daughter.
OTC 52. Go ahead. Okay, we have a new line on 162, and that's at IPR 55 Victor 0151. Copy that, thank you.
OTC, CBSE on 212.
Go ahead, CBSE.
Roger, I want to let you know that step 567 is a not performed.
Next up to enter Columbia is German payload specialist Ulrich Walter. Walter will be working on the blue team during the flight alongside Steve Nagel, Tom Henricks, and our payload commander Jerry Ross.
RSRT OTC.
Walter's a native of Iserlohn, Germany, and holds a doctorate of physics degree in physics from the University of Cologne. He has spent the last 2 years at Houston's Johnson Space Center training for this D-2 mission.
RSRT OTC 212.
outside of his daily duties. Dr. Volter is an avid amateur photographer, and he has said on a few occasions he'll be looking forward to this particular flight when he can get the beautiful photos of Earth.
Okay, that T-by is 2022. Copy that.
Aboard the D-2 mission, Dr. Volter will be primarily responsible for the module's experiments. He will also be an active participant in the Baroflex experiment. This is a study that delves into the causes of lightheadedness, which is experienced by astronauts upon their return to Earth. On many occasions after landing, the astronauts become dizzy and have to be seated in the crew compartment of the orbiter for extended periods of time to more or less get their land legs back following the space flight.
OTC, COSC.
On Ascent this morning, Dr. Volter is outfitted with electrodes and a silicone neck cuff as part of this study of the Baroflex experiment.
CGSS, OTC. This is CGSS. Yeah, step 558, perform your OAA accumulator force charge. Copy, in work. OTC, CGSS. Go ahead. I can verify steps 559 and 560. I copy that. Thank you.
I want to make sure that you can...
This is shuttle launch control at T-minus 1 hour 54 minutes and counting. German payload specialist Dr. Ulrich has just boarded the spaceship Columbia, and next to enter will be mission specialist Charlie Precourt. All in all, our pre-launch operations are going fairly well here inside the Launch Control Center. Over about the last half hour, we noticed some problems with a ground support equipment regulator out at the launch pad. This is a secondary regulator on the Space Shuttle main engine's helium system. What we've seen is that this gauge is reading a little bit lower than it should. The pressurization on it has dropped over the last few hours, and we need redundancy on this particular regulator. And while the secondary or the backup of this secondary regulation system is working fine, the primary is what we have some concerns with. So what we've decided to do is send a red crew out to Launchpad 39A. This will be made up of about 4 individuals who are now being briefed by NASA Test Director Al Safji on the operations they will be doing today. And what we're going to do is go out and tweak this regulator, the primary regulator, and just see if it comes back online, and we'll watch how the system performs. All the technicians and engineers here involved with the main engines believe it is a ground support equipment failure, and we're hopeful that we'll get it back online within the next several minutes. So a decision is being made right now on when we might want to send the red team out to the launch pad, and we will let you know when that occurs. But other than that potential ground support equipment problem out at the launch pad, we're looking at no other issues that would get in the way of this morning's launch attempt at 10:50. Chief Astronaut Hoot Gibson is now flying approaches and touch and goes out at the shuttle landing facility, and will continue for the next couple of hours. We're continuing to look at weather here, but believe it will be favorable at the beginning of the launch window. This is shuttle launch control at T-minus 1 hour 49 minutes and counting. Our NASA test director here in the firing room has informed Red Crew team leader Joe Burney to get his team together and to move over to Complex J, which is a modular facility located just across the street from the Launch Control Center. Once the 3-member crew is organized, they will head out to Launchpad 39A. Again, what they'll be doing is troubleshooting a problem with a secondary or backup secondary regulator on Space Shuttle main engine helium system. We're getting a lower than desired reading on this secondary system, and while the prime is giving us, the prime regulator is giving us a good reading, we need redundancy on this before committing to launch. But managers here are confident that it's nothing more than a ground support equipment problem, and we should know that within the next 20 or 30 minutes once the red crew gets out there and has a chance to check the gauge. No other issues of note being noticed here in Firing Room 1, nor out at the launch pad as we continue preparing the Space Shuttle Columbia for liftoff at 10:50 Eastern Time this morning. At T-minus 1 hour and 48 minutes and counting, this is Shuttle Launch Control.
MS1, com check, NTD, how do you read? MS1, loud and clear. Read you loud and clear, thank you. Houston, MS1, how do you read?
Got you loud and clear, Bernard. Good morning.
Good morning, Chile. EPD, CDRS, and CHDD, OTC.
CHD.
EPD, go ahead. And CDRS. Okay, can you verify all PICs and SNA devices are not armed, range safety inhibit zone, and verify shuttle and GSE detection systems operational? EPD verifies.
HCD verifies.
Copy. And this is OTC on 212 to all personnel during the red crew entry. There will be no LPS programs run while red crew is within the BDA except as required to monitor and maintain vehicle and GSE in a safe configuration. Control switching is in effect. NTD concurrence is required for all switch actions.
This is Shuttle Launch Control at T-minus 1 hour 43 minutes and counting. The 7 STS-55 crew members are now aboard the Shuttle Columbia and being situated in their various seats on the mid-deck and the flight deck of the orbiter. Everything aboard Columbia continues to look very well, and the only problem being that piece of ground support equipment on the mobile launcher platform, which is a secondary helium system regulator on the main engines. It's given us lower than desired readings, so we've decided to send a red team out to Launchpad 39A. They should be leaving from this area within the next few minutes. Again, what they'll be doing out there is more or less tweaking or adjusting this secondary regulator to see if it comes online. The primary regulator is reading the right measurements, so that's what leads management and engineers here to believe that it is nothing more than ground support equipment. Also, we're seeing nothing unusual on any of the main engine systems here in the firing room. Our various support personnel is now on station. These are the people who would be on hand in the event of an emergency landing at California at Edwards Air Force Base or across the ocean at either Benguerir in Morocco, Morone in Spain, or Banjul in the African nation of the Gambia. Also offshore we have a couple of solid rocket booster recovery ships which are standing by to retrieve Columbia's boosters once they are jettisoned away from the ship and splashed down in the ocean. The crew members offshore are faced with seas in the 5 to 7 feet range, and they have southeasterly winds at about 10 to 15 knots.
Okay, thank you.
The boats left Port Canaveral on Friday morning in anticipation of that Saturday morning launch that was delayed roughly 6 hours before our planned liftoff time because of a problem with an inertial measurement unit aboard Columbia. That particular unit has since been changed out and the replacement retested and shown to be very healthy. Offshore, these solid rocket booster recovery ships are now in the process of performing an electronic search of the entire impact area to assure that the waters are clear of all non-authorized vessels. Roughly 30 minutes before launch, the ships will be situated about 5 to 7 miles from the predicted impact points of the 2 solid rocket boosters. It takes roughly about 5 hours from the time the ships reach the boosters to the time that they are able to drain them of water and prepare them for towing back to Port Canaveral. To pump the water out of the boosters, we need to send scuba divers out over the side of the ship, and what they do is they plug the end of the booster, drain it of water, and it goes from a vertical bobbing position to a horizontal position that makes them easy to tow back. Once back at their deservicing hangar, Hangar AF, over on the Cape Canaveral Air Force Station, the boosters are hoisted up and inspected and then disassembled before being returned to their vendor, where they will be cleaned, refueled, and readied for future shuttle flights. Like the Space Shuttle Orbiter, the booster segments are reusable, and each booster segment is designed to be used for up to 20 shuttle flights. Many of the booster segments have flown on several missions already and are showing little wear from all the various shuttle flights. Within the last several minutes here in the firing room, we've activated the ground launch sequencer program at the integration console. The engineers are currently setting up tables in the launch processing system that the GLS or ground launch sequencer will use as its guidelines for allowing the launch countdown to continue. Other recent pre-launch events included the pressurization of the main propulsion system's helium tank, the activation of the solid rocket booster's hydraulic power unit, gas generator heaters, and checkouts of the liquid fuel levels inside the Space Shuttle's external tank. With the exception of this ground support equipment problem, or what we believe to be a ground support equipment problem, with a regulator, a secondary regulator, on a helium part of the main propulsion or space shuttle main engine system out at the launch pad, we're not working any other issues that would impact an on-time liftoff this morning. At T-minus 1 hour, 37 minutes and counting, this is shuttle launch control. This is shuttle launch control at T-minus 1 hour and 36 minutes. On our operational cameras, we have some black and white footage of the 3-member red crew as they approach Launch Complex 39A. Once out of their van, the 3-member crew will head up to the mobile launcher platform. Well, they will take a look at this backup secondary regulator.
Good morning, loud and clear. How are they?
Again, the primary part of this system is working fine, but we do need redundancy, and that's what we're going out to try to establish this morning. The red team is expected to be out at the launch pad around 15 to 20 minutes, and they see it as a relatively simple fix on this system.
Morning, Shelley, you're on clear too.
At the present time, our ICE team leader, Greg Katnick, is briefing Launch Director Bob Seek and NASA Test Director Al Sofchi, along with the Mission Management Team Chairman Brewster Shaw, on his team's findings out at the launch pad this morning as they went out to look for any unusual frost or ice buildups on the external tank and Space Shuttle orbiter. All indications coming back from Greg Katnick are that we saw a very clean vehicle and that he has no problems with anything that he noticed out there.
OTC CGLS 212. Go ahead, GLS. Yes, sir, GLS initialization is complete. Step 659. Copy, 659. OTC, PTC. Go ahead, sir. Okay, at the egress, if we could perform our final ORF status checks. Copy that, will do. OTC to all personnel. SPA will be rebooted to clear the spooler. The SPA will be out of operation for approximately 5 minutes.
This is shuttle launch control at T-minus 1 hour, 30 minutes and counting. Within the next couple of minutes, booster test conductor Harvey Cohen will be verifying that the chamber pressure aboard the shuttle's twin solid rocket motors is at the appropriate level to support today's launch. These transducers or sensors measure the pressure in the thrust chamber at the nozzle of each solid rocket booster. This information is then used to tell Columbia's onboard computers when to separate the solid rocket motors in flight.
Okay.
Separation of the boosters from the Space Shuttle orbiter and external tank typically happens just over 2 minutes into flight.
CDFS OTC. CDFS OTC 212.
This is CDFS.
Just for information, understand we will have a dolly load.
I copy.
OTC MS3 com check. Read you loud and clear, MS3. How many? Hey, Mike, loud and clear. Good morning, Jay. Good morning. MTD MS3 com check. Read loud and clear. How many? Loud and clear, Al. Good morning. Good morning, Al. And Houston MS3 com check.
Have you loud and clear, Jerry? Good morning.
Morning, Tilly. Let's do this thing.
Badge.
OTC GPS, go ahead. So I'd like to request to perform the GMT MET update due to the dolly load that would put us back a little while. Copy that. You want to go ahead and take it off? Yes, sir, that's fine. Like a TC on 152, please. Team TC, OTC. CMTC, OTC. CMTC. Need someone on 152, please. Copy.
This is Space Shuttle Launch Control at T-minus 1 hour, 24 minutes and counting. Operations here in the firing room continuing to go rather smoothly towards supporting an on-time liftoff at 10:50 this morning. The red crew that was dispatched out to the launch pad about 15 minutes ago is out there looking at this secondary regulator associated with the helium system of the Space Shuttle's main engines. And that work appears to be going well also.
Copy that.
This will be the 14th trip in space for the Space Shuttle Columbia. Columbia initiated the Space Shuttle program exactly 12 years and 2 weeks ago today, making her maiden voyage on April 12, 1981. The ship was built by Rockwell International and delivered to the Kennedy Space Center in the spring of 1979. Columbia's last flight in space came this past October, and she is next scheduled to fly on the Spacelab Life Sciences 2 mission late this summer.
And good morning, Ulrich.
There are hundreds of NASA and Lockheed Space Operations Company employees who are assigned specifically to the Space Shuttle Columbia, and it's their job to get the orbiter ship-shape and ready for each mission. The groups are headed up by what we call flow managers from both the civil service and contractor ranks. Our NASA manager responsible for overseeing all the work on Columbia for this particular flow is Bascom Murrah, and his Lockheed counterpart, who was responsible for seeing that they maintained a quality-driven timeline, is Cheryl Hinton. The Spacelab D-2 module, which is the prime payload of this STS-55 flight, is loaded firmly inside the payload bay of the orbiter and ready for its 9-day mission. Over the course of this 9-day flight, more than 90 medical and material sciences experiments will be conducted. Astronaut crew members and German and American scientists have been quick to point out that there will be no immediate results from, or very few immediate results as part of this particular mission, but that what we learn on the D2 flight will be used as a base for flights to come in the future and also for much work in the laboratories that will follow.
Yes, 1 Houston, as you loud and clear. Good morning, Ulrich.
In that regard, it is very much looked upon as a journey to the future.
OTC, this PS2, com check. I read you loud and clear, PS2. How many? Mike, I read you loud and clear, too. And good morning, Hans. Guten Morgen. TTD, this is PS2, comm check.
At T-minus 1 hour, 20 minutes and counting, this is shuttle launch control. Out at the shuttle landing facility, astronaut Hoot Gibson continues flying approach and landings to the 3-mile-long runway aboard a 38 jet trainer.
I read you loud and clear also. Thank
Gibson has radioed back to Dick Richards, who is our astronaut weather officer here in the firing room, that he sees the clouds moving fairly quickly and that he is somewhat optimistic, however not overly optimistic, that they will be out of the area prior to the opening at 10:50.
CVFS OTC.
Over the last several months, the Kennedy Space Center has hosted a large contingent of German engineers who were on hand to help our KSC engineers process the Spacelab D-2 module for its flight. Most of this processing work occurred in the operation and checkout building, which is where we have historically prepared all of the Space Shuttle's horizontal payloads for their missions.
Okay, copy that, and remember we have one...
The NASA Public Affairs Office put together a short video clip which details the ongoing preparation of the Spacelab D-2 module and much of the work that has occurred over these past many months leading up to today's launch and our subsequent flight of D-2.
Okay, copy. I have a copy of the OMI with me, and I have reviewed every switch position. The switches are correct via the...
The Spacelab module being used for the STS-55 D-2 mission last flew in space during the summer of 1992 on STS-50. Following the conclusion of that mission, the Spacelab module was removed from the orbiter and taken to the cleanroom-like environment of the operations and checkout building's high bay. American and German engineers worked side by side during the fall and early winter months of 1992 as they readied and then checked out the scores of experiments that are now just hours away from being tested in the microgravity environment of space. Once the preliminary groundwork on the module was accomplished, the STS-55 astronauts visited the facility to further familiarize themselves with the location of the Spacelab experiments and racks. Here is Spacelab D-2 payload commander Jerry Ross.
Looks like with the camera mounted to this mark, and I do have my fully experiment, but it's flickering very badly. I guess maybe.
Pre-launch processing of the module was completed by mid-January of this year, and Spacelab D-2 was hoisted from its processing stand and set inside a pressurized transportation canister. Spacelab D-2 was then moved roughly 8 miles to the orbiter processing facility, where it was installed inside the payload bay of the orbiter Columbia. The Spacelab D-2 module and the Space Shuttle Columbia were put through several compatibility and integration tests before the 7 astronauts arrived for their last pre-mission of their on-orbit laboratory.
Yeah, that's worthy of comment.
The barrel reflex is not in the same way inserted here as it is into that.
Okay, so it should follow this sequence?
There's a patch right here, but I don't think the thing's installed on it yet.
By early February, all systems of the orbiter and payload had been assembled and configured for flight. Columbia was then mounted atop a special transporter and moved a few hundred yards from the orbiter processing facility to the vehicle assembly building. Five days after joining the other shuttle elements inside the vehicle assembly building, Columbia was rolled to Launchpad 39A, where it now stands poised for flight. The giant crawler transporter that carries the shuttle stack and its mobile launcher platform to the launch pad is a holdover from the Apollo era. Weighing more than 6 million pounds, the crawler meticulously churns its way forward at an average speed of less than 1 mile per hour, well below the center's posted speed limit. Thousands of people from around the world have played significant roles in preparing Columbia and Spacelab D-2 for this historic flight. Before the module was moved to the orbiter processing facility, members of the payload community took a few minutes to band together and pose for a team portrait in front of their mission-ready Spacelab D-2 module.
Loud clear.
And Houston has you loud and clear. Configure for air to ground 2 comm checks.
Stand by one. So we're ready for the air to ground 2 voice check.
Columbia CDR and PLT. Comm check on air to ground 2.
CDR loud and clear. PLT loud and clear.
Houston reads you loud and clear. Configure for UHF comm check.
Stand by. Okay, we're ready for air to air.
CDR PLT Houston on air to air comm check.
CDR loud and clear. PLT loud and clear.
And Houston reads you loud and clear. Configure for simul voice checks.
Just configured for the simul voice check.
Hey, Columbia Houston for the whole crew. Simul voice check. How do you read?
CDR loud and clear. PLT loud and clear. MS1 loud and clear. MS2 loud and clear. MS3 loud and clear. PS1 loud and clear. PS2 loud and clear.
Columbia Houston, we read you all loud and clear. This completes the air to ground voice checks.
OBCCOTC.
Go ahead, OT6.
Yeah, I'll give you a go to close latch, ingress egress hatch for flight for order ops port setup 20.
OVCC copies. That'll be in work.
Okay. OTC DPS, go. Step 635 complete. GMT MET address complete. Ready for IMU attitude determination. Pre-flight aligned. Okay, copy that. And GMC OTC. OTC, go ahead. Yeah, GPS is complete with his GMT and MET adjust. We got to go for 646. Copy. OTC, seal. Go ahead.
Yeah, so I'd like to report an observed condition with one of our flash evap T-line heater temperature transducers. We've seen a couple of excursions down below the LCC lower limit. The heater temperature would typically cycle, but it's bumped the lower limit a couple of times. We don't see it as a real problem, though.
Okay, I copy that. I want to take that to 232 just to let all the test team know when they're finished up there.
Copy.
And OTC to all personnel, you'll have a momentary loss of downlist. And CGNC OTC.
Go ahead.
Also give you step 644.
That's complete.
Copy.
This is shuttle launch control at T-minus 1 hour, 7 minutes and counting. The red crew, which was dispatched out to the launch pad by our NASA test director Al Sopchi and shuttle launch director Bob Seek, is now wrapping up their work and preparing to reboard their van and head back up to the Launch Control Center area.
OTC, ECL 212.
Go ECL.
Can I get a CMQC on 143, please?
CMQC OTC.
Yes, sir, 143.
Thank you.
There's still no report back to the firing room on what happened out with the red crew and the ground support equipment, piece of ground support equipment they were looking at, the regulator. But the belief in here is that it was a GSC system failure and something that the red crew would have easily been able to handle. And I think the fact that they are coming back to the Launch Control Center is indicative that we have a good fix to that problem. The team here in the Launch Control Center continues to move along on schedule and according to the timeline towards preparing Columbia and the 7-member crew for launch from Complex 39A right on time at 10:50 this morning. Out at our shuttle landing facility, astronaut Hoot Gibson has been continuing with his flights aboard a T-38 jet trainer and has reported back to Weather Officer Dick Richards that everything appears to be go as far as he's concerned as the weather pilot. The cloud deck that we thought initially might be below 8,000 feet is fairly stable at the 8,500 foot level. And the thunderstorm cloud anvils that were predicted to possibly be in the Kennedy Space Center area by 10:50 are now expected to be north of us. So the indication is now that we will be in a position where launch should most likely occur on time at 10:50 Eastern Time.
OTC, CAFM.
Go ahead.
Yeah, can I get OVCC to come up on channel 142, please?
OVCC OTC.
OVCC, copy.
Also out at the launch pad at the white room level where the astronauts boarded Columbia just about an hour ago, the closeout crew leader is preparing to finalize operations to close Columbia's hatch for flight. Once this hatch is closed and verified sealed from the outside, the astronauts will start leak checks to ensure the hatch is sufficiently sealed from the inside. Once it is verified internally that we do not have any leak checks, Commander Steve Nagel will oversee pressurization of Columbia's cabin to flight pressure. Within the last few minutes, the Eastern Range has also initiated hold fire checks of its safety system. This is a test designed to verify the ability of the range safety officer to stop the countdown during the final seconds of a launch, should a problem necessitate this kind of action.
OTC CQNC.
Go ahead.
Step 646 is complete, and 658 will pick up for the clock.
Copy that.
Most of the work here in the firing room and out at the launch pad is continuing to go along in a fashion that would support launch on time at 10:50 this morning. At T-minus 1 hour, 3 minutes and counting, this is Shuttle Launch Control. This is Shuttle Launch Control at T-minus 1 hour and counting. All of our pre-launch preparations are now back on schedule, and we're looking to be in good shape towards supporting launch of Columbia and D-2 in 1 hour and 20 minutes. The report back from the Red Crew is that our problem with the backup regulator on the Space Shuttle main engine's helium system has been corrected and that it's back pressurized and reading at the proper level. At this point, there are no other technical issues of note that would stand in the way of launch.
CDR and OV.
Weather is believed to be go at the opening of the window, and unless we see some substantial or dramatic changes within the next hour, it will remain that way. The release of the last Gym-Sphere balloon should be taking place within the next couple of minutes. These Gym-Spheres are small helium-filled balloons that are released at various times during the shuttle launch countdown. The balloons are about 8 foot in diameter and have a silver metallic coating, which makes for easy radar detection. The weather tools are released from the Cape Canaveral Air Force Station and can reach heights of up to 80,000 feet.
Okay.
NASA uses these Gym-Spheres as extremely precise means of determining the upper level winds and directions prior to launching the Space Shuttle or other expendable rockets. We've had a few other Gym-Spheres released over the last 6 hours, and they have all come back with very positive readings showing winds that are well within our launch commit criteria.
OTC, OVCC.
Go ahead, sir.
Okay, initial hatch closures.
All of the systems aboard Columbia are continuing to behave properly and trouble-free at this point as we continue the pre-launch journey leading to the launch of D-2 and the STS-55 mission. Today's launch will mark the 55th time that a space shuttle has been sent up from the Kennedy Space Center. The first shuttle launch occurred just over 12 years ago on April 12, 1981. Bob Crippen was the pilot of that first space shuttle flight, and he is now seated at a management console inside Firing Room 1 of the Launch Control Center.
You ready to perform cabin link check?
Details ready.
And CDR OTC.
Bob Crippen flew once aboard that one trip aboard Columbia and 3 other times aboard the Space Shuttle Challenger before moving up NASA's management ranks to the extent that he's now director of Florida's Kennedy Space Center. The 7 astronauts are now aboard Columbia, and no unusual circumstances are being reported as the closeout crew continues closing the hatch of Columbia. Pre-flight alignment of the ship's inertial measurement units was begun a few minutes ago. This critical guidance and navigation system allows the orbiter and astronauts to determine their locale in space relevant to the stars and fixed geographic locations here on Earth. The alignment of these inertial measurement units will be concluded in about another 40 minutes during the T-minus 20-minute hold. It was an anomaly with the number 2 inertial measurement unit that forced NASA to delay Columbia's launch this past Saturday until today. We had some periodic spikes with the power supply of this inertial measurement unit, and management did not feel comfortable flying with the possibility that we might lose that particular unit once up on orbit. The decision was made to change out the inertial measurement unit, and that occurred over the weekend, and a retest of the replacement unit was successfully conducted. At T-minus 56 minutes, 18 seconds, and counting, this is Shuttle Launch Control.
OTC ECL.
Go.
I need to get a cabin pressure reading on panel 01 from the CDR, please.
CDR, OTC.
CDR, go ahead.
Yeah, can we get a cabin pressure reading for ECL, please?
Pressure on panel 01 is about 15.0. ECL copies 15.0, thank you.
CMPS, OTC. This CMPS, are you ready for the SCARS printer plotter? 671. That's firm. Copy. LPS, OTC. LPS, OTC 212.
LPS.
Yeah, 671, set up SCARS printer plotter.
Copy, stand by. OTC, LPS.
Go.
I'll give you 671.
Copy that. MPS.
MPS copies.
This is shuttle launch control at T-minus 53 minutes, 20 seconds, and counting. Within the next couple of minutes, NASA Test Director Al Sofji will request that the orbiter's S-band communication system, which is used for the tracking, data, and telemetry, be activated so that final checks of communications can be completed. Also, the Merritt Island Tracking Station at the Kennedy Space Center is switching from low power to high power, where it will remain through this morning's launch of Columbia and Spacelab D-2. Once Columbia is off the launch pad, NASA tracking stations will provide the air-to-ground voice, data, and telemetry. During launch, our Mila tracking station will follow the vehicle for the first 6 minutes before turning over to a station in Bermuda. Ground tracking from Bermuda will then continue until 11 minutes after launch, when NASA's tracking data and relay satellite system begins serving as the principal conduit between Columbia, the Mission Control Center in Houston, and the Payload Operations Control Center near Munich, Germany. The TDRS, or Tracking Data Relay Satellite System, will continue serving as the main conduit for communications throughout the STS-55 flight.
And also high cabin pressure.
CDR, you copy?
CDR, copy. And I'd like to also request that CDR state a mark when he gets the master alarm due to cabin pressure.
CDR, did you copy?
CDR, copy.
Thank you.
Yes, sir, I copy. OTC CDR had the master alarm for cabin pressure at about 15.9.
ACL, you copy?
ACL copies, thank you.
CMPS, OTC. Yes, OTC, 672, 673 complete. I give you 674. Copy, thank you. LPS, OTC.
LPS.
Yeah, 674.
Copy.
This is shuttle launch control at T-minus 49 minutes, 54 seconds and counting. The hatch leading to the Space Shuttle Columbia has now been closed for flight, and Commander Steve Nagel just reported back to Mission Control that it has been pressurized to an acceptable level.
29 mainline activation by the clock. We'll copy that. We'll put that in work per the clock. Thank you.
At the shuttle landing facility, astronaut Hoot Gibson continues flying touch and goes. He's now switched from a T-38 jet to the shuttle training aircraft. This modified Gulfstream flies very much like a space shuttle does as far as approach and landings go to the shuttle landing facility. Gibson has been at the runway the past couple of hours flying these approach and landings to the runway and feeding his visual observations back to Flight Weather Officer Dick Richards.
689 RF depth source verification.
What Hoot is looking for is any clouds, the thickness of the clouds, the cloud deck, and any possibility they might have for obscuring the visibility of Steve Nagel if he were to have to come back here to the Kennedy Space Center for a return to launch site abort. Hoot's reporting good conditions, and at the present time, weather does not appear to be a factor hindering an on-time liftoff at 10:50 this morning. Also out at the shuttle landing facility, the landing convoy team has assembled and are readying themselves for this morning's launch. The group is on station at the runway and ready to support an emergency landing of Columbia if we were to have any problems going uphill. Other smaller contingents of Kennedy Space Center workers are also on hand at the shuttle's transoceanic abort landing sites at the Gambia in Africa, Morón Air Base in Spain, and Ben Guerir Airport in Morocco. The weather in Spain is unacceptable to support a transoceanic abort landing. They have low cloud decks and possibility for thunderstorms. Ben Guerir, Morocco is viewed as an alternative site with marginal weather there, but acceptable if need be. The weather in Banjul is acceptable for supporting a transoceanic abort landing, and this African site has been chosen as the prime TOW site for today's launch of Columbia.
Activation by the clock. GPS copy.
During the last few minutes, Columbia pilot Tom Henricks configured the switches to pre-activate the orbiter's 3 water spray boilers. Each of Columbia's 3 hydraulic systems has a water spray boiler that cools down hydraulic fluid and auxiliary power unit lube oil while venting the steam overboard. These water spray boilers are activated during the launch, reentry, and landing phases of flight if the hydraulic fluid temperatures exceed 208 degrees Fahrenheit or if the lube oil exceeds 250 degrees Fahrenheit. These water spray boilers are located in the orbiter's aft fuselage, and they hold nearly 14 gallons of water. The terminal countdown range safety closed loop test is now underway. This test verifies the channels that the destruct signals would travel and that Columbia's range safety receiver is responding to this system check. Console operators inside the Range Control Center over on Cape Canaveral Air Force Station view this as a critical pre-flight check of their entire system. Inhibits have been placed on the command to prevent any accidental firing of the system. All is continuing to proceed smoothly here this morning. The orbiter systems are behaving properly. No big issues being tracked here in the Launch Control Center. And Columbia remains on target for launch in just over an hour. This is Space Shuttle Launch Control at T-minus 44 minutes and counting.
OTC CTLS 212, go ahead. Our mainline activation is complete. Steps 729 through 735. And we'll take a mark out at X on the bypass for IMU hold available timer activation on step 732. Copy that. OTC DTS, go. GPS launch countdown sequence activation complete. Complete through step 750. Copy, 750, thank you.
The 7 astronauts recently took some time out of their schedule to talk about the STS-55 flight, what they hope to accomplish on the mission, and what it means to be an astronaut. Here's mission specialist and flight engineer Charlie Precourt.
I think it first hit me that I wanted to be an astronaut when I watched Neil Armstrong set foot on the moon. I think that was a pretty significant emotional event for all of us. But for me, as a young kid in junior high school at the time, I'd been privileged to be able to fly light airplanes with my dad. I also was very interested in math and science in school. I really loved those subjects and was having a lot of fun with them. And I also liked to build models, especially model airplanes and model rockets. And when you put all those interests together, and after looking into what the men who went to the moon had done with their lives, it all seemed to fall in place that that was the thing to do, the place to go. And I looked forward to it throughout everything that I did in my life, and I'm really happy that it all came together for me.
German payload specialist Ulrich Walter.
I hope that people realize that we can do a lot of useful science in space, but also that space exploration is the next logical step people can and have to do. And of course, it's very important for me that I'm on this mission. Ich hoffe, dass die Leute verstehen werden, dass man eine Menge gute Wissenschaft im Weltraum machen kann. Aber auch, dass bemannte Weltraumfahrt der nächste logische Schritt der Menschheit ist, den man machen kann und machen sollte. Und für mich persönlich ist natürlich ganz wichtig, dass ich dabei bin.
Next up is Mission Specialist and Payload Commander Jerry Ross.
I made scrapbooks about spaceflight even before the first satellites were launched, and very avidly followed each of the manned space flights. When I was in the 4th grade, I decided that I wanted to go to Purdue University and become involved in our country's space program, and that has been the guiding point throughout my entire academic and professional career. And I was fortunate enough then in 1980 to actually be selected into the astronaut office.
Pilot of the STS-55 flight is Tom Henricks.
Go ahead.
I remember the day I received the call to report to Houston for astronaut training. I couldn't contain the excitement. Although my Air Force career was doing extremely well and I was on my way to another school, I dreamed of space exploration all my life. And the realization didn't really hit me until I was sitting on the pad in November of '91 getting ready to launch. And now I'm doing the same thing again, and I still have a difficult time containing the excitement.
Yeah, we're getting ready.
I hope you feel it here today.
Cabin pressure
And
probe.
I hope our country continues to support the space program so that others may experience this same thrill.
I copy that.
Here we have German payload specialist Hans Schlegel.
The D-2 mission is important. From my personal point of view, it is the first mission I take part in. From a German point of view, it is the second mission within 8 years where Germany controls the payload. From an international point of view, it is one of few international shuttle flights, and with this experience of international cooperation, in few years we all want to operate the International Space Station Freedom. From the payload point of view, the D-2 mission is a multidisciplinary mission with 93 experiments. They cover human life sciences, biology, fluid physics, material science, robotics, technology, Earth observation, and astronomy. Most of these experiments are building up on the results of D1 and will contribute to the dynamic process of Micro-G research. Die D2-Mission ist wichtig. Von meinem persönlichen Blickwinkel aus ist es die erste Mission, an der ich teilnehme. Von einem deutschen Blickwinkel aus ist es die zweite Mission innerhalb von 8 Jahren, bei der Deutschland die Payload kontrolliert. Von einem internationalen Standpunkt aus ist es eine von wenigen internationalen Shuttleflügen, und mit dieser Erfahrung von internationaler Kooperation wollen wir alle in wenigen Jahren die internationale Raumstation Freedom betreiben. Von einem Nutzlaststandpunkt aus ist die D2-Mission eine multidisziplinäre Mission mit 93 Experimenten. Sie überdeckt den Bereich der Humanmedizin, der Biologie, der Fluidphysik, der Materialwissenschaften, der Robotik, der Technologie, der Erdbeobachtung und der Astronomie. Die meisten dieser Experimente bauen auf den Resultaten von D1 und werden zu dem dynamischen Fortschritt der Mikro-G-Forschung beitragen.
Mission Specialist Bernard Harris is the flight's medical doctor.
Spacelab D-2, in its conception with the variety of experiments and activities that we have to do in this limited time of 9 to 10 days, is a glimpse of the future. A future that involves orbiting laboratories like Space Station Freedom, like expanded mirror capability, and all of that leading to future colonies on other planets, like colonies on the Moon, or perhaps even on Mars. You see, in that environment, in the space environment of the future, we will be involved in space manufacturing, we'll be involved in figuring out what microgravity actually is all about, and how human beings, which is a special interest of mine, can survive in space. Spacelab D-2 has it all.
Steve Nagel was pilot of the 1985 D-1 mission and today he serves as commander of the D-2 flight.
I'm very excited to be going into space again. It's an opportunity to go back to a place that you've been before, that you know is full of adventure and thrills and excitement, and a place of great beauty. My goals on this flight are first and foremost to have a safe mission and a successful mission, in that we are able to conduct the experiments that we set out to do. Secondly, I would like for all of us, especially the first-time flyers, to have a few free moments during this mission to really enjoy the beauty and the adventure of what we're about to embark upon. It's something that none of us can ever forget, that all of us would like to do again and again. And I'm very thankful to have the opportunity to do this one more time.
This is Space Shuttle Launch Control at T-minus 33 minutes, 18 seconds, and counting. Pre-launch preparations are continuing to go very well here in the firing room and out at Launchpad 39A as we ready Columbia for flight in 53 minutes at 10:50 a.m. Eastern Time. Several minutes ago, NASA Test Director Al Sofji was informed that the Eastern Range has completed all of its command checks and that the Shuttle Range Safety System closed-loop test was successfully performed. Confirmation was also received that the orbiter's S-band communication system has been placed in the high power mode in preparation for this morning's launch. The Superintendent of Range Operations has notified the NASA Test Director that the range is ready for launch, signaling that the downrange shipping stations are clear, the booster splashdown area is open, and that all necessary downrange tracking stations are up online and ready to support launch this morning.
Go ahead. I can give you step 736. The crew module pressurization and initial cabin leak check is complete. We're ready to proceed with cabin vent redundancy configuration.
The ground launch sequencer mainline computer program has also been activated and is now in the midst of processing data. This program monitors various key commands and systems prior to its assuming control of the countdown at the T-minus 9 minute and counting point. In about another 10 minutes or so, Shuttle Weather Officer Ed Priscillik will present Launch Director Bob Seek with a detailed overview of weather for this morning's launch. Observations being noted at the Cape Canaveral Air Force Station and by pilot Hoot Gibson out at the shuttle landing facility indicate that we have a go situation. Right now all of the weather codes are green, and if the weather continues to cooperate and the vehicle continues to look as good as it has over the last several hours, we should have launch on time at 10:50 this morning.
RTC CDR, the cabin vent ISO is closed, talkback closed, the vent is open, talkback open.
Copy that, then.
The orbital maneuvering system gaseous nitrogen tanks have now been pressurized for launch and are in the process of being checked out. The gaseous nitrogen is used to operate the valves which allow the hypergolic propellants to flow into each of the ship's 2 orbital maneuvering system pods. These orbital maneuvering system pods are what are used to maneuver the space shuttle while up on Earth orbit, and they are also used for our deorbit burns at the end of the mission. The deorbit burn is what takes the space shuttle out of its Earth orbit and brings it on its way home. NASA Test Director Al Sofji has also ordered the post-launch inspection and safing teams to begin assembling at the roadblock adjacent to the Launch Control Center. This team will head out to Launchpad 39A after launch and begin cleaning off the mobile launcher platform and the launch tower.
OTC CDR, the past BFS transfer prep is complete.
Copy that, sir, and I'll also give you a go to perform your OMS GN2 press.
Roger, the OMS GN2 press is in work. OTC CDR, OMS GN2 press is complete.
Copy that, thank you.
Within the past minute, a byte check or pre-flight software validation of Columbia's master events controller has been successfully performed. This MEC, or master events controller, relays the commands from the orbiter's computers to fire the explosive charges to the solid rocket booster hold-down bolts at launch.
COSC.
It also executes the commands to separate the boosters and external tank away from the space shuttle on ascent.
COSC, copy.
At T-minus 28 minutes, 36 seconds and counting, this is shuttle launch control.
OTC LPS.
Go ahead.
781 complete.
Copy. OSC, you copy. COSC, copy. ODCC, OTC.
Good, OTC.
Yeah, I give you official closeout white room go.
Hi, copy. We're just finishing up with the hatch.
Understand?
I'll let you know when that's complete and when we're going to start the white room.
Copy.
OTC, SIM
Go.
Line on 163 was deferred.
Copy.
OTC ECL.
Go ahead.
I can give you step 754. Final cabin leak check is now complete.
Copy that, and 755 is yours.
Okay, I'll give you a DPDT of minus 0.001.
Copy that.
And we are ready for cabin venting.
HGD, OTC.
HGD.
You copy 756.
I copy.
CDR, OTC.
CTR, go ahead.
Yes, sir. You can open the cabin vent isolation valve, and you may get a klaxon and master alarm and just reset.
Roger, cabin vent ISO coming up and down.
OTC EPD.
Go.
Yeah, I'd like to have your concurrence to go ahead and proceed with step 791 for MEC 2 flight byte.
There we go.
EPD copies.
And OTC CDR, the cabin vent is complete. Cabin vent ISO is open.
Copy that. ECL, OTC.
ECL copies that, verifies 759 and acknowledges 762.
Copy that.
OTC CGLS.
Go.
Yes, sir, GLS limit change and dual notification for BRS. PRS is complete. Step 794.
Copy 794. CDR OTC.
CDR, go ahead.
Stand by to perform SIMO air-to-ground voice check.
CDR, Roger, we're ready.
Columbia, Houston for the whole crew, comm check.
CDR, loud and clear. CLT, loud and clear. MS1, loud and clear. MS2, loud and clear. MS3, loud and clear. CS1, loud and clear. CS2, loud and clear.
Columbia, we have you all loud and clear, and a minor change here to your KSC RTLS page when you're ready to copy.
Stand by one, please. Okay, Chili, we're ready. Go ahead.
Okay, we're going to be looking at nominal aim point. You can expect 21% speed brake at 3K. Touchdown is 2,200 feet down the runway. No change to the altimeter. Winds are 180 at 12, gust 16. And I've got delta to your band jewel information when you're ready for that.
Okay, we copied. Change the aim point to nominal. 21% speed brake, 2,200 feet down the runway, winds 180 at 12, gust to 16, and we're ready for the band jewel update.
Hey, Steve, for band jewel, we're looking at nominal aim point now. Short field speed brake. Speed brake at 3K will be 42%. Touchdown, 1,600 feet down the runway. How copy?
Okay, nominal aim point, short field speed brake, touching down 1,600 feet down the runway with 42% speed brake.
Good readback.
This is Space Shuttle Launch Control at T-minus 22 minutes, 26 seconds and counting. Pre-launch preparations of the Orbiter Columbia and the rest of the STS-55 launch package are continuing to go very smoothly here this morning as we prepare for liftoff at 10:50 a.m. Once Columbia gets off the launch pad, control of the vehicle will be handled by the Johnson Space Center in Houston, Texas. Mission Control will maintain control of the Shuttle Columbia all the way through wheel stop after a touchdown here at Kennedy Space Center on May 5th.
Cabin is closed out.
We will now turn control over to the Johnson Space Center to hear an update on how they are prepared for this morning's launch.
This is Mission Control Houston at 21 minutes and 36 seconds and counting in the preparations for the launch this morning. The Ascent Flight Control team here in Mission Control has been on duty since about 4:30 this morning and continue to closely monitor all of the systems aboard the orbiter. All flight controllers have notified Flight Director Wayne Hale that they're ready to support the 14th launch of Columbia this morning.
Go ahead.
A review of the weather conditions at contingency runways at the launch site in Florida as well as overseas shows that conditions are currently favorable to support a landing if one becomes necessary during the launch phase of the mission. The current primary transatlantic abort landing site is Banjul, the Gambia, with two other locations at Ben Guerir, Morocco, and Morón, Spain, unavailable due to poor weather conditions at the present time. Once Columbia lifts off, the vehicle will roll to a heads-down position, putting it on the proper course to achieve an orbit about 160 nautical miles above the Earth. At about 30 seconds into the flight, the three main engines will be throttled back to lessen the effects of the dense lower atmosphere on the orbiter. Less than a minute later, the shuttle will accelerate rapidly, reaching a speed of about 3,700 miles per hour when the twin solid rocket boosters will burn out and separate at about 2 minutes into the flight. Once in orbit, Columbia's engines will be shut down at the 8.5-minute point, followed just a few seconds later by the separation of the large fuel tank. spacecraft communicator Kevin Chilton just conducting SIMO voice checks with the crew and updating the crew commander Steve Nagel of the landing conditions that he would experience at the Kennedy Space Center and at Banjul, the Gambia, should those landings become necessary during the launch phase. All continues to go smoothly here in Mission Control, with flight controllers standing by to take over control of Columbia and the STS-55 mission at liftoff. At T-minus 20 minutes and holding, this is Mission Control, Houston.
This is Space Shuttle Launch Control at T-minus 20 minutes and holding. A good report coming back from Houston's Johnson Space Center that Mission Control is up and ready to support this morning's launch of Columbia and Spacelab D-2. This is the first of 2 remaining build-in holds planned for this morning's launch countdown. This planned hold at T-minus 20 minutes is scheduled to last 10 minutes. The next hold at the T-minus 9-minute mark is also 10 minutes in duration. During this planned hold, NASA Test Director Al Sofji will be asking members of the launch team to verify that the proper computer software has been loaded for the remainder of today's countdown. Sofji will also get confirmation that the pre-flight alignment of the inertial measurement units has been completed. Landing and Recovery Director John Guidi.
My name's Al Sofji. I'm a NASA Test Director at Kennedy Space Center, Florida. Sometimes you'll hear that abbreviated NTD. We're sitting in firing room 1 in the Launch Control Center at Kennedy Space Center.
Landing and Recovery Director
During the
John
final
Guidi
hours
has
of launch
just
countdown,
reported that
my primary
everything
function
is go at the shuttle
is
landing
to lead
facility
the launch team
and that his
that's
crew is ready and
responsible
configured for launch.
Fueling the external tank with the liquid oxygen and liquid hydrogen, loading the astronauts into the orbiter crew compartment, performing the final checks of all the onboard systems that are required for launch, and eventually launching the Space Shuttle system. The launch countdown begins approximately 3.5 days before the actual launch, but now we're concentrating on the final hours and minutes of that launch countdown. The team that launches the Space Shuttle is composed of about 200+ engineers who are sitting here in the firing room. The engineers here today in the firing room are some of the world's leading experts on every system of the Space Shuttle. A couple of examples of the types of systems and specialties involved in a countdown are the fuel cell engineers, who are responsible for operating the fuel cells that produce the electricity for the orbiter when it's on orbit, and the Space Shuttle main engine engineers, who are responsible for the checkout of Columbia's engines and their computers, or as we call them, engine controllers. While leading the launch team during the final hours of the countdown, I'm also in constant communication with the astronaut commander, Steve Nagel, our launch director, Bob Seek, our chief engineer, Charlie Abner, and other key members of the launch team, such as the orbiter test conductor, Mike Key, the tank booster test conductor, Harvey Cohen, and the payload test conductor, Tom Andranis. As you can imagine, the shuttle system is a fairly complex system, and there's quite a bit of preparation and integration that goes into preparing for a launch countdown. I'm also involved in all of that preparation required to get to today and to eventually launch the shuttle system.
DVD OTC.
This is DVD.
Yeah, we did not reposition any vent doors, so we cannot perform 819 through 21.
That's negative. We need to reposition forward vent doors.
Okay, copy that.
And can we put that in work?
You may. I'll give you a go on 819.
TC CSCP.
Go ahead.
There you go, CMQC on 153 and permission to pick up with 912 with the count.
CMQC OTC.
CMQC.
Yeah, I need somebody on 153.
Copy.
And which step was that, SCP?
912 purge.
Yeah, copy that. You have a go.
OTC ECL.
Go.
I'll give you step 805. Cabin venting is complete, and we're ready for a cabin pressure reading.
Copy that. CDR OTC.
CDR, go ahead.
Yes, sir. On panel 01, can you report cabin pressure?
Stand by. At OTC CDR, it's 15-0 on the overhead.
Copy that. ECL 8070.
Okay, for 807, recorded cabin press of 14.76.
Copy, and CDR, can you go to CRT3 and report cabin pressure?
Roger, stand by.
This is shuttle launch control at T-minus 20 minutes and holding. We have just over 4 minutes left in this planned build and hold in the countdown. Our shuttle weather officer, Ed Priscillic, has just briefed the NASA launch director, Bob Seek, on today's launch conditions. And it appears that we are go for the opening of the window at 10:50 this morning. Meteorologists from Houston Space and Meteorology Group have also informed the launch team that Banjul is indeed the prime contingency transoceanic abort landing site, and that we do have acceptable conditions overseas.
Copy that, sir. Thank you, and that takes us up through 813.
OTC CPVD.
Up until this point in the countdown, the many console operators here in the firing room have been talking on isolated voice channels. At the conclusion of this T-minus 20-minute hold, everybody will switch over to the same channel, which is available or allows immediate access to the NASA test director, Al Sofji. From now through the launch minus 31-second point, any of the console operators here can request that the countdown clock be held if a problem is detected.
KVFX. KVFX verifies. CDFS OTC. CDFS OTC. 212.
Shuttle weather officer Ed Priscillic's observations coincide with those of Poot Gibson, the chief astronaut who is out flying touch and goes on the shuttle runway. They both see go conditions here at the Kennedy Space Center, and it appears that we will be able to meet an on-time liftoff at 10:50 this morning. Columbia remains in good shape. The weather is acceptable, and we are now just 2 minutes away from coming out of our planned build and hold at the T-minus 20-minute mark. This is shuttle launch control.
CDFS OTC. DPS OTC. DPS go? Yeah, is VFS back there? Yeah, they sure. Stand by.
OTC CFS.
Go ahead.
Okay, use of LDB is complete and Star Trek door open indications are verified off. That's steps 831, 32, and 33.
Copy that.
CDFS?
Yeah, can you verify 828?
Step 828 is verified, and the RAS number is 055.14.
Copy that, thank you.
NTD on air to ground 1. The countdown clock will pick up in 45 seconds.
CRPS OTC.
CRPS.
Step 840.
And we can verify it's complete.
Copy. DPS OTC.
This is Shuttle Launch Control at T-minus 20 minutes and holding. NASA Test Director Al Sofji has informed the team to pick up the count on time. T-minus 4, 3, 2, 1. We're now at T-minus 19 minutes, 58 seconds and counting. A purging of Columbia's fuel cells is now underway, and dumping of computer software from one of the 4 general-purpose computers is just 3 minutes away.
I can also verify 775.
Copy. OTC, DPS? DPS, OTC. Yes, sir, go ahead. Yeah, can you verify step 877 to concurrencies? Yes, sir, sure can. Thank you.
We're now at T-minus 19 minutes and counting. The transitioning to the primary Ascent software is now complete, and Columbia's computers are in the primary launch program, which is also known as Ops 101. Mission Commander Steve Nagel is now configuring the backup flight system so that it matches the primary program. All continuing to look very well at T-minus 18 minutes, 44 seconds and counting.
OTC, DPS. Go ahead. Pass Ops transition complete. GPS ready for BFS transition to Ops 101. Copy that. That's step 916. Sir, firm. OTC, PTC. Stand by, please. OTC to all personnel. After transition to Ops 101, discontinue all LDB PMU reads for the remainder of countdown. PTC, go ahead.
Yeah, step 96. Orbital receive SM alert and backup caution and warning tones from Spacelab during Ops 1 transition.
Copy that. DPS, TPE, ISL, you copy? DPS
ISL
copy. FCO, NTD on air ground 1212 contract. How do you read? FCO, NTD 212. CDR, OTC.
CDR, go ahead.
Yeah, take BFS to Ops 1 per your checklist.
Roger, in word.
PLT, OTC.
Go ahead.
Yeah, configure pass and BFS horizontal fit displays per your checklist.
That's in word. Good, OTC, CDR, BFS is now on Ops 1, no unexpected faults.
Copy that, CDR. And CDR, OTC.
CDR, go ahead.
Yeah, configure contingency abort yaw steer per your checklist.
CDR, Roger, in word.
NTD CVFS,
Go ahead, CVFS.
ready for BFS uplink.
Flight NTD. Flight NTD, step 936. You can perform the DFS2 flight uplink loading.
We'll put it in work, NTD.
This is Shuttle Launch Control at T-minus 15 minutes, 20 seconds and counting. Within the past several seconds, NASA Test Director Al Sofchi has requested Houston flight controllers to send their pre-flight uplink command to the orbiter's backup flight system. Pilot Tom Henricks is also in the process of performing the main propulsion system helium system reconfiguration. This procedure opens the helium isolation valves necessary for the in-flight purges of the shuttle's engines, and it provides an emergency source of pressure for the pneumatic shutdown of the engines. The water levels aboard Columbia's water spray boilers are also being checked and verified to be sufficient for the flight.
212 and 232 conducting the briefing. Window opens at 1450 GMT and closes at 1720 GMT. A second
Configuration of the cross-feed valves between the orbital maneuvering system and reaction control system propellant tanks has been performed, and orbiter test conductor Mike Key has requested pilot Tom Henricks to report the quantities of propellant inside the reaction control system tanks.
Perform AP start upon command of OTC only.
PLT's copies and the MTIC limerick config is complete.
All right. CDR, pad egress system is nominal. Evacuation helipad is 8.
CDR copies.
Firing room launch team disable telephone ringers at this time. Ingress and egress of the firing room will not be allowed after resuming the count at T-minus 20 minutes until after launch or flight crew egress if a recycle occurs. If there is an extended hold at T-minus 9 minutes, limited firing room access will be allowed. All personnel not active in terminal count will monitor OIS channel 217. All personnel bear in mind that critical post-launch operations will be in progress after a successful launch, so keep firing room activities and noise to a minimum. After T-minus 5 minutes, any hold, manual or GLS, should be accompanied by a description of the problem and a recommendation. The count clock will continue until T-minus 31 seconds unless the recommendation to hold at the next milestone is necessary. Problem resolution and discussion will continue in parallel with the count preceding the T-minus 31 seconds. Are there any questions? That concludes the briefing.
MTD STM.
Go ahead, STM.
Yes, I'd like step 966, please.
NASA Test Director Al Sofchi has just briefed the launch team here on their duties and responsibilities for the remainder of today's launch countdown. Systems aboard Columbia continuing to look very well at T-minus 12 minutes, 49 seconds and counting. This is Shuttle Launch Control.
Good, sir. Step 962 and 963 are verified at this time. That's all non-essential personnel have cleared the LDA. That's correct, sir. STM 964, you can terminate video track and recording of the closeout crew. STM copy. STM copy. Go ahead, STP.
Yeah, 967, fuel cell purge complete, ready for load adjust.
Copy that. EPD, SCP, ECL.
EPD, ECL.
SCP.
SCP.
Okay, step 969, adjust fuel cell loads.
EPD copies.
SRO entity. Countdown clock will hold in 2 minutes, 42 seconds.
NTD ISL.
Go ahead, SL.
Yes, we need to begin with the OEX recorder configuration.
Okay, you ready for that now?
Yes, sir.
Houston Flight RPS entity. RPS. Houston Flight entity.
MTD Houston Flight.
972, you can activate the OX recorders.
We'll put that in where?
And RPS copies.
And NTD ISL, I'd like to CMQC on 145 also.
CMQC?
CMQC.
145.
This is Space Shuttle Launch Control at T-minus 11 minutes, 9 seconds and counting.
Dump is complete. Step 970.
In the last couple of minutes, we've received verification that the contingency support is ready and that aircraft and emergency teams are on station and ready for launch. The T-minus 20-minute dump of the orbiter general purpose computers memory banks has also been completed, and there were no surprises seen in this system. NASA Test Director Al Sofchi recently informed the team that the countdown clock will hold as planned at T-minus 9 minutes. We are now just about 1 minute and 30 seconds away from the last of today's scheduled build-in holds, planned for the 10:50 launch of Columbia and Spacelab D-2. Solid rocket booster test conductor Harvey Cohen is now verifying that the hydraulic unit power levels in the twin boosters are at a proper level for launch. Columbia's onboard computers are also adjusting the flow rate of conditioned air being fed into the orbiter's payload bays. Once this is complete, the flow rate will be sustained at about 180 pounds per minute. Launch systems continuing to look very well. At T-minus 9 minutes, 47 seconds, and counting, this is shuttle launch control.
Into the SRO on 212.
SRO reporting that the KSC area is clear for launch.
I copy.
And how are you coming on your reinitialization?
We are coming along. We're in the middle of testing at this moment. We expect another 10 to 15 minutes.
Copy, we'll stand by.
Copy.
NTD Houston Flight 212.
Hey, flight.
Yes, sequence 16, step 991, the IMU misalignment correction, and sequence 994.
This is shuttle launch control at T-minus 9 minutes and holding.
And so forth.
This hold is planned to be 10 minutes in duration, but it can be extended at the discretion of the launch director, Bob Seek, if need be.
NTD, STM.
When the countdown resumes, the ground launch sequencer will be in control of all activities. This master computer issues the commands to perform the final critical tasks, which are required to place Columbia in the proper launch configuration.
Configuration is not complete.
The ground launch sequencer also monitors nearly 1,000 different parameters during the last 9 minutes of the countdown to assure that they neither drop below nor exceed their rated values. At this point, all continuing to look very good aboard Columbia. Several key milestones remain between now and launch of Columbia. Once we come out of this planned hold, the ground launch sequencer will take charge and begin controlling all the commands of the shuttle systems for all the critical tasks. One of the most important events during this planned hold is the poll of the mission management team, which is conducted by Mission Management Chairman Brewster Shaw. He has recently notified his team members that he will be proceeding with his poll within the next few minutes. Following the poll of the mission management team, Shuttle Launch Director Bob Seek will conduct a poll of Space Center management here and assure that everybody is go and green for launch. At this point, there is nothing standing in the way of launch of Columbia this morning. We are looking good for an on-time liftoff at 10:50. We have just over 7.5 minutes left in our planned build-in hold at T-minus 9 minutes and holding. This is shuttle launch control.
NTD Houston Flight 212.
Go ahead, Flight.
Step 1011, we have one change or note for the crew we'd like to call up, please.
Yeah, now's a good time.
Columbia, Houston, with your predicted max rates in first stage when you're ready to copy.
Standby 1 Charlie. Houston, go ahead.
Hey, Columbia, maximum roll rate in first stage is 2 degrees per second at 50 seconds. Pitch, 1 degree per second at 40 seconds. And yaw, 1 degree per second. You can expect roll oscillations between 50 and 80 seconds.
Oh man, we're gonna have to send a
And we
plane up.
expect a nominal
Oh, okay.
trajectory in second stage.
Okay, copy. Roll 2 degrees a second at 50 seconds. Pitch 1 degree per second at 40 seconds. Yaw 1 degree per second. Roll oscillations from 50 to 80 seconds in a nominal second stage.
Good read back.
ISL RPS, Houston flight entity. RPS.
Houston flight.
ISL.
Yes, step 1018, you can activate recorders.
Copy that.
RPS copy.
Flight copies.
This is NTD on air to ground 1, taking a status check for launch. Say go, no go for launch. OTC. Go. TBC. Tank and boosters go. PTC. Payloads are go. LPS.
Go.
Houston flight.
Go.
Mala.
Mala, go.
STM. STM go. Safety. Safety go. SP. SP go. CDR.
Columbia's go.
LRD. Go. And SRO.
This is SRO NTD. Can you stand by 1 minute? We believe we got our problems fixed, and I will report back in just a few moments.
Copy.
OTC, NTD.
Go ahead.
I can give you step 1034 at this time.
Copy. The launch director, NTD, everyone's go except the SRO, and he thinks he's going to be go here momentarily.
We copy. And we'll do the management poll at this time. Payload Operations Director. Payloads a go, Bob. Copy, John. Engineering Director.
Bob, engineering's go.
Copy, Bob. And Safety and Quality.
Safety and quality's go, Bob.
Okay, Al. And Cape Weather.
Launch director, we have no weather constraints to launch, over.
Copy. Ed. And Ops Manager, Launch Director.
Bob, the MMT has no constraints to launch. You're clear to proceed.
Yes, sir. And NTD, based on everybody being green and the range expecting to get there momentarily, you should plan on coming out of the hold at the nominal timeline. And we'll plan on holding at 5 minutes, and if range does not go before then.
Understand.
And Columbia Launch Director looks like a good opportunity, so we're going to make a run at it, Steve.
Okay, Bob, thanks again to you and the whole team for all your efforts. We appreciate it, and we're ready to go and see you in about 10 days.
Okay, and on for Hans and Ulrich, ein guten Flug. Galuk.
Oh, vielen Dank, das brauchen wir. Und nochmals, vielen Dank.
Copy.
Countdown clock will pick up at T-9 in 2 minutes and 30 seconds.
NTD, ISL.
Go ahead, ISL.
Recorders are now activated.
Copy.
This is shuttle launch control at T-minus 9 minutes and holding. Some good news coming from the firing room here. We have 3 successful pulls. Brewster Shaw, our mission management team chairman, conducted a silent pull of his team.
SRO on 212.
And everybody on his side is go. NASA test director Al Sofchi conducted a poll of his crew, and with the exception of the range, everybody was go. The range is working a computer problem on their end, but we expect to have it completed on time to support launch at 10:50 this morning. Shuttle launch director Bob Seek conducted a poll of the team in the firing room here, and everybody is go, again waiting on the range to clear up their problem. Seek made the decision to proceed with picking up the countdown on schedule, coming out of the T-minus 9 minute hold but added that we may throw in a hold at the T-minus 5 minute mark if the range still has not completed their obligations.
7 o'clock, we'll pick up the T-minus.
And wishing the crew off to a good flight, Bob Seek made a few comments to German payload specialist Ulrich and Hans Schlegel. He told the German astronauts to have a good flight, and we'll see him back here in 10 days. And it was responded with some German words back to Bob Seek from the payload specialist.
NTD SRO and 212.
The launch team is very upbeat here, and everything appears to be running very well towards supporting launch of Columbia at 10:50. In the last couple of seconds here, the range has responded to NASA Test Director Al Safji that we are go for launch. So with that taken care of, all the players in today's launch countdown have completed their obligations, and nobody has any concerns or problems that would stand in the way of an on-time launch at 10:50 this morning. Just 4 seconds from coming out of this hold. 2, 1. We're now at T-minus 8 minutes, 59 seconds, and counting.
Sequence has been initiated. FCO, NTD, contact here to ground 1.
The ground launch sequencer has now been activated, and the STS-55 terminal countdown is underway.
FCO on air to ground 1.
All of the countdown events are now being handled by the ground launch sequencer up until the T-minus 31 second mark, when responsibility for the countdown is handed over to Columbia's onboard computers. T-minus 8 minutes, 22 seconds, and counting.
NTD FCO.
Yeah, contact air to ground 1. How do you read?
And you're allowed clear.
Okay, stay with us on air to ground 1, please. PLTOTC. Configure fuel cell essential bus source switches. Copy.
We're at T-minus 7 minutes, 34 seconds and counting. At T-minus 7 minutes, 30 seconds, the ground launch sequencer will initiate retraction of the orbiter crew access arm. And that is now in work. This access bridge can be positioned right back to Columbia within about 15 seconds, should the need arise.
TLS entity. Yeah, let's go. Yeah, you copy. We will not hold at 5. We copy.
T-minus 7 minutes and counting. NASA Test Director Al Safji informing the ground launch sequencer console operator that we will not be holding at T-minus 5, so we remain on schedule for launch at 10:50 this morning. T-minus 6 minutes, 30 seconds, and counting.
KRPS, start APU and hydraulic strip chart recorder. Hydraulic and APU strip chart started. And PLTOTC, perform APU pre-start.
APU pre-start support.
Orbiter test conductor Mike Key has just given pilot Tom Henricks an OK to begin the auxiliary power unit pre-start procedure. Henricks is now setting the switches in the cockpit to put the auxiliary power units in the pre-start configuration. Auxiliary power unit start comes in.
PLT 3 great top net.
Copy.
Pilot Tom Henricks reporting that the auxiliary power units look good. The systems will be activated in 30 seconds at T-minus 5 minutes. These auxiliary power units provide the power to the hydraulic pumps, which control critical tasks like the movement of orbiter elevons, the rudders, the speed brake, the landing gear, and the main engine thrust vector controllers. Mission Control has just transmitted a signal to start Columbia's onboard flight recorders.
Genesis go for orbiter APU start. PLT OTC, perform APU start.
APU starts and work.
Test.
And CDR reconfigure heaters.
CD Roger and work.
Test conductor Mike Key has given pilot Tom Henricks the go to start the auxiliary power units, and Henricks has flipped the proper switches. Commander Steve Nagel has reconfigured Columbia's heaters for launch. Just 4 minutes, 30 seconds away from liftoff of Columbia and the Spacelab D-2 module.
APU starts complete.
Copy that.
At T-minus 4 minutes, 14 seconds, a final purge sequence of Columbia's main engines will begin. The test of Columbia's flight controls is now starting. The engines should be being gimbaled. Also during this time, the aero surfaces such as the rudder, elevons, and speed brake are being cycled through a programmed test pattern to verify that they are up and ready for launch. T-minus 3 minutes, 30 seconds, and counting. Columbia's main engines are now positioned for launch, and pressurization of the external tank is underway. T-minus 3 minutes, 3 seconds, and counting. Momentarily, the retraction of the external tank's gaseous oxygen vent hood should begin.
Pressurization. PLT OTC, clear cost and warning memory and verify no unexpected errors.
Clearing the faults.
The gaseous oxygen vent hood is being retracted away from the external tank. And Orbiter Test Conductor Mike Key has requested Tom Henricks to clear the ship's caution and warning memory system. That task is reported complete with no anomalies. T-minus 2 minutes, 5 seconds, and counting.
And flight crew, OTC, close and lock your visors and initiate O2 flow and have a good flight.
Good work, and thank you very much.
Genesis go for EP, LH2, pressurization.
The astronauts have closed their flight visors on their helmets in preparation for this morning's launch. Replenishment of liquid hydrogen to the external tank is also being terminated, and Columbia is disconnected from all ground fuel loading systems. T-minus 1 minute, 30 seconds, and counting.
1 minute, 30 seconds.
T-minus 1 minute, 15 seconds, and counting. The ground launch sequencer is now verifying that Columbia's 3 main engines are ready for ignition. The heaters around the joints of the solid rocket boosters are being turned off. In another 15 seconds, we'll get the command for auto sequence start.
Genesis go for auto sequence start.
We have a go for auto sequence start. The baton has been passed from the Launch Control Center computers, and Columbia is now in charge of its own launch countdown. T-minus 20 seconds. Columbia's vent doors are being moved and configured for flight. T-minus 15, coming up on a go for main engine start. 12, 11, 10, T-minus 9, 8, 7, 6, 5, 4, 3, 2, 1. Solid rocket ignition and liftoff. Liftoff of Columbia on a voyage to the future.
Roll program, Houston.
Roger, roll, Columbia.
Houston is now controlling, the roll maneuver underway and complete. Columbia is in a heads down position, on course for a 28.5 degree flight, 160 nautical mile orbit. Engines aboard Columbia now beginning to throttle down as the orbiter passes through the area of maximum pressure on the vehicle in the lower regions of the atmosphere. Columbia is now just 1 nautical mile downrange from the launch site at an altitude of 17,000 feet. Accelerating now through 680 miles per hour. Engines are now beginning to throttle back up.
Columbia, go at throttle up.
Go at throttle up.
All 3 engines are back at full throttle. Hydraulic systems and electrical systems performing well aboard Columbia. 4,000 feet, range from the launch site 8 nautical miles. Columbia is now traveling 1,700 miles per hour. The next event is burnout and separation of the twin solid rocket boosters. That comes at about 2 minutes and 4 seconds. SRB separation is confirmed. Columbia is now 29 miles from the launch site at an altitude of 173,000 feet, traveling 3,000 miles per hour.
Columbia, performance nominal.
Performance nominal.
Columbia, 2-engine Banjul.
2-engine Banjul.
Performance thus far in the mission has been as expected, and Columbia can reach Banjul, the TAL site, in the event of a single engine failure. However, all 3 engines are still performing at full throttle. 3 good hydraulic systems and electrical systems aboard Columbia. The orbiter is now 55 nautical miles downrange from the launch site at an altitude of 248,000 feet, traveling 3,400 miles per hour. Time now 3 minutes and 30 seconds into the flight. Flight controllers reporting all systems still performing well. Aboard Columbia, the orbiter is 112 miles downrange from the Kennedy Space Center at an altitude of 330,000 feet.
Columbia, negative return.
Negative return.
Columbia can no longer return to the Kennedy Space Center in the event of an engine failure. Four minutes, 35 seconds. Columbia is at an altitude of 355,000 feet, downrange from Kennedy 165 nautical miles, traveling 8,300 feet per second, or about 5,700 miles per hour.
Columbia, press to ATO.
Press to ATO.
Columbia can reach orbit on 2 engines should one fail. All 3 continuing to perform at full throttle. Hydraulic systems and electrical systems performing well. The orbiter is 211 miles from the launch site at an altitude of 371,000 feet, traveling 10,000 feet per second, or about 6,800 miles per hour.
Columbia, press to MECO and droop band Joule 109.
Press to MECO and droop band Joule 109.
Time 5 minutes 45 seconds into the flight. Columbia can reach safe orbit on 2 engines. However, all 3 are still performing at full throttle. Hydraulic systems are looking good, as are the fuel cells aboard the orbiter. Columbia is now 290 miles downrange from the Kennedy Space Center at an altitude of 375,000 feet.
Columbia, single engine band Joule 104.
Single engine band Joule 104.
The orbiter can reach band Joule and the Gambia on 1 engine should 2 fail at this point. Columbia is traveling 8,500 miles per hour.
Columbia, single engine press 104.
Single engine press 104.
Time 7 minutes 10 seconds. Columbia can reach orbit on 1 engine should 2 fail. However, all 3 are still performing at full throttle. The orbiter is 478 nautical miles from the launch site. The altitude is 360,000 feet. Speed now is 12,200 miles per hour. Have about 1 minute remaining in the powered flight of the 3 main engines aboard Columbia. The engines are beginning to throttle back to maintain the structural limits on the orbiter as it approaches loads near 3 times gravity. Time 8 minutes into the mission. Columbia is downrange from the launch site 600 nautical miles. Altitude is 355,000 feet. Columbia's speed is now 14,600 miles per hour. Standing by now for confirmation of main engine cutoff aboard Columbia.
MECO, Houston.
Copy MECO, Columbia.
Booster officer reports the MECO was on time. Kevin Chilton radioing to the crew as Crew Commander Steve Nagel reported that as well. The orbiter nose will pitch up forward just a little bit to plan for the separation of the external fuel tank.
Nominal MECO, Ohms 1 not required. Your go for the photo DTO.
Roger.
The external tank has separated from Columbia. The orbiter is safely in orbit now. Downrange from the launch site 900 nautical miles. The crew's been given a go for the external tank DTO. That's a detailed test objective. The orbiter will conduct a maneuver to pitch around so that the crew members can photograph the external tank as it falls away from the orbiter. This is Mission Control Houston. We will be conducting some replays of Columbia's launch just a few minutes ago. In the meantime, Flight Director Wayne Hale is polling the room here to get a go to shut down the auxiliary power units. Those are the power units used to produce hydraulic power to the orbiter. Those are not needed anymore during the on-orbit phase of the mission. They will be used for the entry phase.
Columbia Houston coming at you through T East. We would like you to hold off on APU shutdown until we can verify water spray boiler activation.
Okay, we'll delay APU shutdown.
Columbia Houston for Tom, we saw 3 good water spray boilers. Your go for APU shutdown on time.
Okay, APU shutdown's in work.
Pilot Tom Henricks aboard Columbia given the go to shut down the auxiliary power units. Those are the hydraulic systems that are used by the orbiter's engines during the ascent phase. also by the movable surfaces on the wings and tail during the entry phase. Those are no longer needed for the on-orbit phase of the mission, and Henricks will be turning those off now that now that it's been confirmed that they have good cooling using the water spray boilers on those systems.
Houston, Columbia, we're in free drift for Tomex at this time.
And we copy, thank you.
Mechanical Systems Officer reports a good shutdown of the auxiliary power units. Flight Dynamics Officer reports that the orbital maneuvering system burn upcoming to circularize Columbia's orbit will occur at 39 minutes 54 seconds into the flight. We're currently at 17 minutes 45 seconds. So that's about 22 minutes away. Again, that will circularize Columbia's orbit at about 160 nautical miles.
Columbia, Houston, we're ready for a debris report at your convenience.
Okay, stand by one. Okay, Chili, for the left side, right around max Q, just a few smudges on the windows. It didn't look abnormal. Around Mach 10 or 11, saw some white, small white flakes going by the left side. It could have been ice. It was not hitting the windscreen. It was going by the left side. And then the only noteworthy thing was after ET-SEP, I saw a great deal of venting out the left side, coming from the aft left side, that I don't remember from before. It could have been normal, but you might ask about it.
Okay, we copy.
It looked almost like a water dump would, with just a shower of very small particles.
Okay, I understand that you saw that out of W1 there, Steve, just to your immediate left.
Yes, W1, it was coming from somewhere further aft on a vehicle.
Okay, we copy.
And Houston, Columbia, on the PLT side, we saw the same as Commander saw at 20. At higher Machs, the debris seemed to be all on his side, and you can tell the folks at Banjul were passing overhead, and we got a great view of them today.
Okay, Tom, we'll pass that on. Columbia, Houston, we like your OMS 2 targets and solution.
Copy that. We'll stay in free drift if you concur for another few minutes here, then maneuver.
And Columbia, we concur with free drift.
Roger.
Houston, Columbia, the MPS power down complete. We've activated the vacuum inerting, and we're about to close the ET doors.
Hey, we copy, Tom. Thanks.
Columbia's crew is performing routine post-ascent activities aboard the orbiter. Much of that and some of that includes dumping residual fuels out of the engines in preparation for the upcoming orbital maneuvering system burn that will circularize Columbia's orbit. That burn upcoming in about 16 minutes. It will burn both of the orbital maneuvering system engines. Those are the two smaller engines on the tail of the orbiter that produce about 6,000 pounds of thrust each. They will burn for about 2 minutes and 23 seconds and change Columbia's velocity by 222 feet per second, basically bringing the orbiter up to about a 162 by 160 nautical mile orbit. Checked several of the flight controllers on the ascent, and all agree that it was a nominal ascent with no systems problems on the way uphill at all. The orbiter's in very good shape at this point now, just about 25 minutes into the flight.